Hey, it's Jag. Today I'm unboxing some new test equipment. Well, I'm still mostly taking a break and tinkering. It's still fairly early in July. But I did order some test equipment that I've been needing for a couple of years, and that has all come in. So I thought I would pop down and unbox these three pieces of equipment and show you what I got. I got a new digital oscilloscope. Several years ago, my old Tektronix analog scope bit the dust in a big way, and it just wasn't worth repairing, and I didn't have enough knowledge of the internal workings of an oscilloscope to try and fix it myself. So I let that one go, and I've been working with a really cheap USB oscilloscope since, and I've found it's just not convenient to use. It has to plug into a computer, has to have software for the computer. All the buttons are on the computer. I really don't find it convenient to use, so I never do use it. And I don't need an oscilloscope that often. If you're building tube amps yourself and you're building one or two every few years, you probably don't really need an oscilloscope. But I'm going to be doing a lot more on my channel with electronics over the next while, and I really do need a good oscilloscope. So I finally decided that I need an oscilloscope I'll use. After doing a bunch of looking around and watching the guys that I watch for electronics on YouTube and seeing what they use, I saw that Regal was used quite a lot. Siglent is used quite a bit too. I picked this oscilloscope because all the people that I watch on YouTube, more of them had Regal oscilloscopes than any of the other brands. Siglent would have been second. So I got this one, and we'll unbox it. So there we are. It's all packaged fairly well. Power cable, USB cable, and the oscilloscope itself, manuals and test probes. We'll look at that in a minute. So there we are. It's the Regal DS1054. I wanted a 4-channel oscilloscope. They're not really necessary, but to me it made a lot of sense. I can monitor, for example, if I'm tracing signal through an amp, I can monitor the input. I can monitor output of the first stage, the second stage, going into the phase inverter, coming out of the phase inverter, going into the output transformer, coming out of the transformer, etc., etc., and I can monitor multiple of those at a time. So it made a lot of sense to me. Probably most of the time I'll end up using just 2 channels. This isn't really going to be a demonstration of the oscilloscope. It's really an unboxing. I will fire it up and run some signals into it just so we can see the basic operation. But there we are, the Regal DS1054. It comes with 4 probes. I believe they are. I believe they have a times 10 switch on them. Yes, they do. So times 1, times 10. It's kind of, I think, rare to not have that switching on there. I also have a times 100 set of probes for if I'm reading stuff that really goes off scale. But we got probes with the color-coded mounting rings and all of the little extra cap covers and the adjuster. We also get, of course, the power cable. A USB cable. So there is USB software that you can use for this. You can, I believe, capture your data. You can transfer screen captures and whatnot. I think you can even control this through USB. I'm not likely to do that. I'm an old school guy. I like knobs and buttons and being able to touch things and see things happen. We'll fire that up in a bit, but I'm going to unbox the other 2 pieces of equipment here. These all go together in terms of what I will be using them for. So the other piece of equipment that I needed was a decent function generator or signal generator. I have another little cheap hobbyist one that worked well enough, but was really hard to fine-tune the adjustment of how of the level of the output and a few other things. It just kind of seemed pretty flaky and flimsy. It was just a little tiny USB powered thing, and I didn't like it much. So I wanted to get a decent signal generator. I didn't really, it's not a piece of equipment I'm going to use for much more than just injecting a 1 kilohertz signal into an amp to trace it through, change the frequencies anywhere between, maybe 30 and 15 kilohertz, but I didn't need anything super special. I'm not going to do any digital work, so I don't need a lot of the other waveforms that it can generate. The square wave and the sine wave will be basically all I use, maybe sawtooth. I didn't go super name brand. I was looking around on Amazon and I found this. It's a very generic signal generator. You see it under a bunch of different names. It just says signal generator on here, and on the unit itself, at least in the picture, it says signal generator. There's no real brand name. When I ordered this on Amazon, it says it's a Coolertron DDS signal generator, but I've seen this exact same generator under a number of different names. I did check some reviews on YouTube, and for what I'm going to do, I think it's going to work great. It's a very, it's got some nice features and functions, but it's not super advanced. And like I say, I really only need sine wave, square wave, and maybe sawtooth. So we'll open this one and see what we get here. And again, we get USB cable. We get a manual. Oh, this is nice. So we get BNC connector with alligator clips at the one end for injecting your signal. We get 2 of those. This is a 2-channel signal generator, which is nice. You also get a BNC to BNC connector, so you can connect right out of this into, for example, your oscilloscope, if you're calibrating or doing other things like that, or you have other equipment with BNC inputs, you can use this. More often than not, I'll be using the BNC connector and alligator clips to inject signal into various points in the tube amplifiers when I'm testing them or scoping them out to see how everything's looking. Power cable again, and the unit itself. Here we are, and yeah, it does say signal generator. Very basic function operation, power switch, your wave, your sweep, your types, all of that can be chosen on here. Again, I'm not demonstrating these. This is just really an unboxing. It's a very light unit, but I think this will work well. So the third and final piece that I'm unboxing today, and it's a little heavy, and you'll see why once I get it open. I have wanted and needed for a long time an isolation transformer. If you don't know what an isolation transformer is used for, when you're testing something, for example, like an amp, and you have very high voltages in there, the isolation transformer, it takes the line AC input. It's a 1-to-1 transformer, so you have 120 volts coming in, and it outputs 120 volts, but there's no physical connection between the input and the output. That isolates the whole circuit under test from the mains, and it makes it much safer. You can't, as long as you're using it properly, you can't complete a path by touching something, one hot point in the amp, and accidentally brushing an earth ground and complete a circuit and get a shock from that. You can, when you're using it from a point to another point in the device under test, you could complete a path and get a shock. So it's not like you can just randomly start touching everything in the circuit, but it just gives you some safety. It can also protect the equipment you're testing with. For example, an oscilloscope, the ground probe on the oscilloscope, or the ground connection on the oscilloscope probe, is direct to chassis ground, which is direct to neutral ground and earth ground. So if you were to connect that ground somewhere to a hot point of a circuit without the isolation transformer in between, you'd create a direct short from the device through to earth ground through your oscilloscope, and at the very least you would damage your probe, Probably you would damage the oscilloscope as well. We'll talk about using the isolation transformer in another video down the road sometime. I will demonstrate what the purpose of this is. I also want to demonstrate the purpose of a variac. There are reasons for having this equipment. It's part of your overall test bench setup if you're going to be doing this kind of work a lot. So that's enough of that for right now. Let's take a look at what we get in here. A power cord, and the transformer. It has a multifunction display. As far as I know, you can't really choose what it displays. It just shows you your input voltage, your current draw, just some basic information on what's happening. Your on-off switch here. I didn't realize, because it didn't show in the pictures, but it uses these universal receptacles. I don't really like them, and they're not code in some places in the world, basically because just about any plug from anywhere in the world you can plug into one of these. So if you wired this to a 220 supply, let's say you're in Europe, you can still plug a US cord straight into it for 120 and blow up whatever you're plugging in, or cause other problems. But I'm aware of that, and I may go to the extent at some point to replace these sockets, but this will only be used here in Canada and only used for 120. And I know what I'm doing. I know what I can plug in. It'll just be either 3-prong 120 plugs or 2-prong 120 plugs. We got our IEC connector. It has this mode switching here, which says standard and special. My understanding is that's switches it sort of between what would be medical isolation transformer, which just isolates for noise and carries the chassis ground through from the isolated outputs through to your mains, and it's really just there to deal with line noise, etc. It also has the special mode, which does not carry that ground through, and that's what we call a tech level isolation transformer, where the ground does not continue through the device under test to earth ground. Anyway, that's my isolation transformer. These three pieces of equipment plus the variac make up your essential bench testing setup if you're working on a lot of amplifiers. The way that this will be set up and these will be set up to work together, I will cover in another video. But these are all going to be really great pieces of equipment for me to have, especially as I move forward now and finish the bass preamp. That's coming up. I want to check the DC ripple on the power supply, check how clean the outputs and inputs, etc. are. The oscilloscope and signal generator will be great for that. The isolation transformer is going to be really good when I'm poking around inside there with the high voltages. And a variac is really good when you're testing a device and you don't know what condition it's in. You can bring it up slowly. You can watch for excessive current draw. You can watch for all kinds of other things that could be wrong with the device you're testing without just throwing 120 volts at it, blasting it, and maybe just doing irrecoverable damage. There's another piece of equipment, a fifth piece of equipment that goes in along there as well, which is a dim bulb current limiter, which is a very great piece of testing equipment to have. You can make it yourself for about 10 bucks, 20 bucks. And if you're working on amps, even if you don't have any of this other equipment, you should have a dim bulb tester, because it will save you from potentially frying your transformers in your tube amp. For example, if you don't know the condition of it, if you are even building one amp, look it up. Build yourself a dim bulb tester. And even if you're building a kit and you're sure you've done it all right, fire up on the dim bulb tester first to make sure you've wired everything. You don't have a short somewhere that could damage your newly built kit amp. I'm going to check all of this equipment out to see how it works. So I will get set up for that, and we'll be back in seconds for you, probably half an hour for me. All right, I've got the oscilloscope and the signal generator set up on my bench here. We'll fire those two up, and we'll just make sure we're getting displays on the screen, and that the signal generator is sending signal over to the oscilloscope. I'm not going to do a demonstration of these. For one thing, it's been quite a few years now, 3 or 4, since I had my old oscilloscope, and the digital ones are quite a bit different. I need to learn how to work it. Same thing with the signal generator. It's not very complicated, and again, what I'm doing is very kind of basic, but there are things I'm sure that I'm going to need to study and review and refamiliarize myself with. So this is just a quick demonstration of these two. I'll pull up the ISO transformer after I do this as well. There's not really anything too exciting to show with that. It's more a concept of what an isolation transformer does than something you can say, oh, look at this, and you see on the screen what happens. There are certain things we can do to show sort of what the function of it is. I'll maybe do something really quick about that. We will fire it up so you can at least see the front panel and see that it works. Here is the Rigol DS1054 and the Coolertron signal generator. Both of them obviously turned off right now. Let's fire them both up and see what the startup process is. So here's the Rigol first. A little bit of fan noise, not too loud, nothing that'll bother me in here. Still initializing. There we go. It has fired up. So there we have our home screen, shall we say. It's ready to go. Fire up the Coolertron. See what its process is for starting. And there we go. That started up pretty quick. Initializes at a 5-volt peak-to-peak 10 kilohertz wave, sine wave. So let's just connect channel 1 output from the signal generator to channel 1 on the oscilloscope, and just see if we can get some waveforms. All right, there you go. I'm just going to press auto here. Takes about 7 or 8 seconds. And there we go. We got a nice view of the sine wave coming out of there. Again, 10 kilohertz. We can position it up and down. We can set our trigger level. Where was that? That was over here. Trigger level. Like I say, there's a bunch of other menu options and things that I'm going to need to get familiar with. Over here on the signal generator, I'm more often than not going to work with a 1 kilohertz signal for testing, and usually at lower than 5-volt peak-to-peak. So let's take this down to 1 kilohertz, which is what I will more regularly use. And let's take the peak-to-peak voltage, the amplitude down a little bit. Let's take it down to... Let's take it to 1 volt. A little hard to work with the camera in front of me here. And we'll auto range again. Okay, I think there's it's losing trigger here. I'm gonna do a little bit of familiarizing myself with this equipment over the next while, and we'll sort that out. So now what I've got it set to is just a 1 kilohertz signal, and we can see things quite clear here. Let's put a few different waveforms in here and see what we can get. There we go. So we got sine wave. Let's go square wave. Pretty good looking square wave. We can go for Let's go for sawtooth. And let's go back to sine wave. So, we know the gear is working. I'm going to spend a little time, like I say, familiarizing myself with it. And I'll be using that to check out the bass preamp as we get close to finishing it. I'm really wanting to use this to check the AC ripple on the DC supply once we get that built. So hopefully that will even be in the next video. We'll see. I'm going to take this stuff down, set up the isolation transformer, and at least show you that it works. I'll be right back. Well, I've set up the ISO transformer on the bench. It's turned off right now. I have connected my my multimeter to the outputs on the back just so that we can see that we're getting voltage out of the back. There's not really much else to display or show. Nothing super sexy here, folks, but we can see it turn on and see what the display tells us. So there, we turn it on. It gives us incoming voltage, 122.1 volts right now. It's drawing 0.03 amps. Not really any significant draw there. It's just what the unit itself is drawing. Shows us the power consumption. It shows us power factor and shows us the line frequency. So we, basically we have 122 volts coming in at 60 hertz, which is what we should expect in North America. Are we getting any voltage on the outputs? Let's have a look. It says we're getting 123.3, so not an exact one-to-one transformer in here, but a volt, half a volt higher on the output is kind of to be expected when you're running through a transformer. I did open this up and have a look. It's a really nice toroidal transformer in there. But basically that's the isolation transformer, proof that it's working anyway, and you can see what we've got on the display. There you are, my new test equipment and all the associated goodies up here on the bench, ready to be used. As I say, I've got to spend some time getting familiar with this new equipment, making sure I know all of the ins and outs of the functioning of it. Shouldn't be too hard a haul, but got to do some homework. I'm really glad to have this. As I said, these three pieces of equipment, along with Variac and the dim bulb tester, are really essential once you get to another level of amp building, where you really need to know what's going on with your amp for safety, for troubleshooting problems, even for a perfectly working amp, just checking how everything's looking all the way through the circuit. The oscilloscope's going to be great for that. So for me, a very exciting unboxing today. I'm really looking forward to working with this. I'm also really looking forward now to getting back to the bass preamp. I've had a lot of time to think about some stuff on that, and I can't wait to get back to it and get it finished. So like always, please like and subscribe. Check my band One Soul Thrust. The links are below. And until the next video, we'll see you.